So hello everyone, welcome to this new video. So till now we have solved all the 4 to 5 problems in our previous 2 to 3 sessions of Windows designing of FIR low pass filters. Okay, now in this session I am going to solve one problem just to make you clear about one problem related to high pass filter. Okay, the steps, we have some slight changes in the steps. It would be a bit lengthy process because we are having two set of integrals here, not one, because it is here high pass filter. Okay, I've told you right how high pass filter works. It allows only high frequency components with the outer integral ends, that is from minus pi to pi. So here in this case the value of omega c, they have given it as 2 radian per second. So the two set of integrals are, these two are high frequency components and low frequency components are 0. This is minus pi plus pi. So here the omega c is 2, so this is minus 2 to 2. So these are the two set of integrals. One is from minus pi to minus 2 and one is from minus 2 to plus pi. Okay, then you should be summing those two, adding those two separately and solving it. Okay, so that's why I've taught to solve this high pass filter. One problem is required, very important. It might be asking in the exam. So let us solve this problem, very easy problem guys. One slight change is there in a few steps. I'm going to tell you when I solve the problem. So till now, those who have not watched my previous videos of low pass filter FIR problems using Windows, all different kinds of Windows, so along with formulas and in detail explanation is available in our channel. Please do watch that videos. Okay, so let us get to the question. The sixth question of this series, that is design a FIR high pass filter. HPF stands for high pass filter using Hamming window. They have given Hamming window. Using Hamming window you should be solving this with omega c, that's the cutoff frequency they have given, it is equal to 2 radian per second and the length of the filter is equal to 7, that is n equal to 7. So yeah, let us solve it now. First step remains the same. Find the value of alpha n minus 1 by 2, that is 7 minus 1 by 2. 7 minus 1 is 6 by 2. 2 ones are 2 3s are, so alpha is equal to 3. Okay, now write hd of omega value. That is equal to e power minus j 3 omega. Okay, and now the limits are two different limits. That is, one limit is for minus pi to minus 2 and one more limit is from 2 to pi. Okay, and other side is 0 since we are using high pass filter. Now hd of n. So here we are having some slight change, that is 1 by 2 pi, limits are from minus omega c to plus omega c. hd of omega e power j omega n d omega. So this is the formula, right? Now in this formula 1 by 2 pi into, we have two set of integrals now. Okay, one is from minus pi to minus 2 and these terms would be remaining as it is, that is e power minus j 3 omega e power j omega n d omega. So this is one set, plus second limit is from 2 to pi. Again the same thing, e power minus j 3 omega e power j omega n d omega. So like this the whole thing would be. And now again the same thing, nothing much to do. How we have solved previously, that only 2 times you should be solving. Okay, that is 1 by 2 pi e power j omega n minus 3 divided by j n minus 3. I am directly integrating it. Okay, and the limits are from minus pi to minus 2 plus again e power j omega n minus 3 divided by j into n minus 3 and the limits are from 2 to pi. Okay, substitute the limits. After substituting the limits, you can see that the denominators are common, right, for both j and minus 3. So you would be having one common denominator. Okay, that is j n minus 3, and here we are left with e power, first is upper limit minus 2j, in place of omega substituted minus 2 n minus 3 minus e power minus j pi n minus 3, right, then plus, here the upper limit is e power j pi n minus 3 minus e power 2j n minus 3. Okay, like this we have written it, grouped it together. Now we should be doing slight changes here. We should be writing according to the formula, right? The formula for sine theta is e power j theta minus e power minus j theta divided by 2j. According to this, we should be rearranging some of the terms and writing. First, we can see that we have these two set of terms, that is e power j pi n minus 3 minus e power minus j pi n minus 3. It is according to this formula only. So write that first. This term you write it first, e power j pi n minus 3 minus e power minus j pi n minus 3 divided by, so what I am taking here, I am taking pi n minus 3 outside here from this, okay, pi n minus 3 outside, and I am keeping here 2j, according to the formula I am writing it, okay. Next here we have, these two terms are over, we are left with e power minus 2j n minus 3 minus e power 2j n minus 3. If you observe carefully here, the terms are same here, but the signs are changed. Here we should be having minus, and here we should be having plus, right? If you want to satisfy according to this formula, the signs are opposite. That is, here we should be having minus and here we should be having plus. But instead of that, we have here plus positive term and here negative term. So for that, I am taking this negative common term outside and I am replacing this polarities. That is, here in place of minus I am writing plus. So this term would be e power 2j n minus 3 minus, this term I am taking it to minus, so minus e power minus 2j n minus 3 divided by 2j again. Now these two terms are also satisfied by this formula. Okay, so that's why our final answer would be hd of n is equal to, for this it is sine of, in theta, in place of theta we have pi n minus 3 divided by this here. So again we are having this common denominator for both terms. I am writing it together here, pi n minus 3, okay, and here minus this term. Here in this case it is, the value of theta is 2 times n minus 3, right? So it is sine of 2 n minus 3. So this is the value of hd of n for n not equal to 3. Okay, like this you should be solving for high pass filters. Okay, keep it in mind. Similarly, let us solve for n equal to 3 now. For n equal to 3, the value of hd of n is equal to, take this part of the equation, that is e power j omega n minus 3 j n minus 3 integral minus pi to minus 2 d omega plus 2 to pi, again the same thing, e power j omega n minus 3 d omega. Okay, so here in place of n you substitute it as 3, so these both would be equal to e power 0. So we would be left with hd of n is equal to 1 by 2 pi into d omega, integral of d omega is omega for limits minus pi to minus 2, and here we have again omega for limits 2 to pi. So substitute the limits, 1 by 2 pi is equal to minus 2 minus of minus pi, upper limit minus 2 only, that is equal to plus pi, then plus upper limit is pi minus 2 lower limit, right? So our answer is hd of n is equal to 1 by 2 pi minus 2, that is minus 4, pi plus 5 is 2 pi minus 4. Okay, our answer is 2 pi minus 4 divided by 2 pi. So what I am taking is, I am taking this 2 common here. So what we are left, 2 into pi minus 2 divided by 2 pi, right? I have taken 2 common here in this numerator so that we can cancel 2. So we are left with pi minus 2 by pi. So divide pi individually, that is pi by pi minus 2 by pi. Pi by pi is 1. So our final answer of hd of n we are getting is equal to 1 minus 2 by pi. Okay, so this is the answer of hd of n. So we have got two answers. One is sin pi n minus 3 minus sin 2 n minus 3 divided by pi n minus 3 for n not equal to 3, and one is 1 minus 2 by pi. Let us solve that and let us see in the decimals what is the answer. 1 minus 2 by pi. 0.3633. That I am writing it here. 0.3633. This is for n equal to 3. Okay, now let us make the table. N equal to 7. Put all the values of n from 0 to 6. HD of n, that is this whole big equation is to be substituting in the calculator. While having these big equations, you should be very careful by putting the brackets. Okay, please put the brackets very carefully. That I am going to tell you how. Next is omega of n. This is using Hamming window. Okay, again we have one formula for that, and finally h of n. Right? Yeah. So first let us see the value of HD of n. That is this equation. See the very carefully the equation. First put the outer bracket. Okay. Then write sine. Since we have this whole term in one bracket, right? So sine of, again pi and n minus 3. Again open a bracket and write pi. Close the bracket. Open a minus 3. Now close for this bracket here. Minus. Now you write this term, that is sine of, again open the bracket 2 a minus 3, close the bracket twice, and close the final bracket which you opened at the first, right? That you close. Now whole divided by pi into a minus 3. Now press the calcs and check all the values. For 0 it is 0.0296. For 1 it is 0.1204. For 2 minus 0.2894. For 3 here we have already written is 0.3633. Again for 4 it is minus 0.2894. For 5 it is 0.1204, and for 6 it is 0.0296. Mirror images. Okay. This is done. Now for Hamming window omega n, the formula for Hamming window is 0.54 minus 0.46, that you know, right? Cos 2 pi a divided by n minus 1, that is 7 minus 1 is 6. Okay, so calc button. Again for 0, check the value. This is 0.08. For 1 it is 0.31. For 2 0.77. For 3 it is 1. Again for 4 it is 0.77. For 5 0.31 and 0.08. Okay, now multiply 0.0296 into 0.08, that is 0.0023. Okay, 10 power minus 3, right? 0.1204 into 0.31, 0.0373. Next is 0.2894, 77, 0.2228, and here it is 0.3633 since we are multiplying it by 1. So this is 0.2228. Here we have minus sign, minus 0.2228. Here it is 0.0373 again, 0.0023. So these are the filter coefficients for this problem. Okay. So yeah, that's all for this problem. This was one problem that I needed to explain you all for a high pass filter, because this problem might be appearing, these kind of problems of high pass filters, because this is a bit time consuming, and for exam they always give time consuming problems. So That's why. So please, these problems would be appearing. So that's why we have taken around 15 minutes to solve this. How quickly I've solved it, but still I've taken 15 minutes for this problem. So you should be very quick in the exam. Within 10 minutes, you should be solving these problems. Okay. Yeah. So that's all for this session, guys. Like, share, subscribe to our channel. Do watch our videos regularly. We'll see you in the next session. Thank you.